We're looking at the standard sine function in red. As it oscillates, imagine it going around the unit circle, peaking out at 1, shrinking back down again to 0, down to -1, and up again as it goes around and around. What I'd like to do now is turn on this blue graph where I have the multiplier of a on the outputs of this function. So if I increase this to 2, I can see that I've bumped up all of the values by a factor of 2 across the function. And if I were asked from the graph to tell the amplitude of this particular function, I would measure the distance from the center line to its maximum or minimum point. So from the center line on the x-axis, I can see that it goes up to a maximum of 2, and from the center line at the x-axis down to -2. I can shrink this back down to 1. Let's change it to 1. This graph. Similarly, we can adjust the value of d being added on to the function, and we see we get that vertical shift from the original sine function with this little snippet of the sine function that we're looking at. Note that I've restricted the domain for this purple slice of the function to be between 0 and 2 pi over b. b is currently 1, so between 0 and 2 pi, just to sort of see the behavior as we transform this sine function. So let me move up and down, and if I move it up by 1, I can see that the center line of this sine function has shifted off the x-axis and is now at a line y equals 1. But the amplitude is the same, because the distance from the center line, or displacement from the center line, is still 1 unit, from 1 to 2, and from 1 to 0. So the amplitude of this function hasn't changed, it is still 1, and all I've done is shifted the center line of the curve. No matter how much I mess with this function and the parameters a and d, you can sort of imagine these lines denoting how much that function shifts up and down, but that distance from the center line to the peak and the trough of the sine curve is still just 1. If I increase that to 2, I can still see, no matter how I shift this, transform it vertically, that the displacement, or the distance between the center line and the top and the bottom, remains to be a measure of 2. That is how we define the amplitude of function, the displacement from the center line to its maximum and minimum values. So that will not change, and that is something we're going to be asked to do, to calculate the center line and the amplitude by just looking at a graph. And we'll cover that in a second. In this current case, we can see pretty obviously that the center line has been moved up to 1, and that its amplitude is also 1. The displacement from the center line to the maximum and the minimum is 1 unit. However, it's not always so obvious, so we want to be able to create as an algorithm to find that center line. Essentially, if we locate the maximum point on the curve and a minimum point on the curve, we can add those two y-coordinates together. The value of 2 plus 0, divide that by 2, and we found where the center line would be. 2 divided by 2 is 1. We can see that clearly here. Additionally, we have an algorithm to find the amplitude. If we find the maximum point on the graph and the minimum point, and subtract 2 minus 0, divide by 2, again we get 1, the center line. But it's not always so easy to discover that position. In this current case, I can't quickly and easily identify where the center line is going to be and what the amplitude might be. So employing this algorithm is essential here. I can find the maximum point and the minimum point of the graph and do some quick calculations with our algorithm to figure this out. First, taking the maximum point, 1.6, adding that to the minimum point, -4.4, I get negative 2.8, and then dividing that entire quantity by 2 gives me negative 1.4. And if I turn this into a line, I can see the center line of this particular sine curve. And I can trust the algorithm that has given me the proper line for the center. And similarly, to find the amplitude, take the same two values, 1.6, the maximum value, but in this case I'm going to subtract the minimum value and divide the entire quantity by 2. And I found that the amplitude is 3 units. So from the center line, negative 1.4, to the peak, 1.6, that I've moved 3 units to get that. And we can confirm that from the, graph itself, which I have here, that the amplitude, 3, and the center line, how much it's moved off of the x-axis, negative 1.4. These are the types of problems you might be asked to do in some exercises. So just follow the simple algorithm, but try to understand that where these algorithms come from is related to the ways that we are transforming the original sine function, altering its amplitude and altering its center line. That's the transformation that gives us a new graph, and the algorithm that allows us to find the values of a and d in a algebraic form of this function.